Hey everyone, welcome in the final episode of the third tutorial generating or building a password generator CLI application with Rust, the third tutorial in this channel. And I hope you are enjoying the tutorial so far. In this final episode, we'll introduce like new features, we'll make it more dynamic for the user to select the type or the nature of the password, and also we'll do a bit of refactoring to allow standard error handling within the application. So as usual, let's go to development directory and then go to the demos directory and then go to the demos password and open my code editor. Let me put it that way, and yeah, this is the final stage, and as usual as well, let's write our to-do tasks for today. So for today, we will start with adding more features to the password generator, and then we will like wanna make sure that everything works. Everything works, and yeah, before we make sure that everything works, we wanna do some do refactor for a standard error handling, and make sure that everything works. I think that's summarize what we'll do today in this final episode. Let's start with the first one, adding more features to the password generator. So to allow more features in the let's go to the library, and the features I'm talking about is like allowing adding more flags to the end user, so the end user can select the nature of the password. The like she or he like needs it only lowercase, only numbers, only uppercase, etc. So we will allow this here in the arguments. We'll accept more arguments. So I'm gonna accept like is uppercase, and it will be a boolean, and then like today I'm using I will keep my Copilot up and running just to save some time. If you are not familiar with what like I'm doing, or if you noticed something that you are not comfortable with, like get back to the episode that we explained the struct opt in details, and then you will get familiar with what is being filled here automatically. So here in I have the lowercase, but if you notice, like we also use the length, the short as L. So just in this case, I'll just use for lowercase, I'll just use the W, and then I'll have as well is oh sorry, this is lowercase, and let me use like is uppercase and generate its derive uppercase. I'll use up here. And we have as well is numbers, and the final one samples or special. I prefer the term special, and that's it. So we are now like accepting four more arguments or flags or attributes to the application, so the user can pass like he wants or she wants like lowercase, uppercase, numbers, and special. So to make this work, we will go to, so here in the self, I need also to assign those. We can expand on all the args here, and just let's make sure that is. So yeah, this is like expanding on the args, like expanding it all the inner arguments that I'm accepting from the environment. So just let's make sure that everything works. And also, like, yeah, a quick hint here, you don't need to define a default value for the Boolean because like it's a true or false, the default will be always false because if it's not like passed within the argument, so the default will be always false. So you don't need to pass something like default value here for an integer. Okay, let me do cargo run and then let's try to generate a password of length 12 and see something wrong, wasn't expected. Okay. Length L, okay, lowercase, uppercase. So what's wrong? Yeah, you need to just like this. Okay, very good. So yes, so now we are receiving all the arguments, and let's make it work within the password board. Like if you remember from the previous episode, we segmented the application into two entities. One entity for receiving all the arguments, and the second entity for managing the password with its own internal features. And this will like make our life easier. So you'll notice like today refactor will be built on top of that. So we refactored the part within the arguments to accept more flags, and now we are going to the password to allow it to do what we want to do. So here we will go with like charge pool, and for the charge pool, I will define like a vector, a new one, a new empty vector, and that's it for the charge pool. And then I will go with the checks. So I'm checking if like rx dot is lowercase, and then here I'm extending the charge pool from A to Z. Yeah, need this to be mutable so we can extend. So here, if you check this code, like here, if the user checked the lowercase, want lowercase on the password, and just extending the charge pool from A to Z in small case or lowercase. Same thing, we'll go with args dot is uppercase. I will wait, yeah. And as you can see, like extending from A up until Z. And as we mentioned before, like this equal sign means included. We mentioned this in the first episode using the map. Yeah, here, this one, I mentioned it when we were using this. Then I have lowercase, I have uppercase, and then I'll also, is numbers, I'm extending the numbers. And finally, if what's missing, lowercase, uppercase, yeah, if our special I believe it's just the specials. Oh, it's related to special symbols. Okay, special symbols, no worries. So I'm adding the special symbols, and yeah, because like you cannot add the range object because those are random. So I'm just adding them to the charts. So now you might think of like, what if the user didn't pass any of those, because all of them are options and optional. So you will end up here adding a validation. As you can see, like I did it in the practice. So if the charge pool is empty, yeah, here it's filling it from A to Z, but like I prefer like returning an error to the end user. So I will just panic for now. Um I'll just panic and then I'll refactor it in a bit. So if the user didn't pass anything, we will panic. So let's give it a try. Yeah, here I'm just, yeah, it should panic. Yes, you must select at least character set because I didn't pass anything. So let me pass like uppercase. So we are good, everything in uppercase. Let me combine uppercase and numbers. So yeah, we have uppercase and numbers and it's good. So this is the first part. We now have like more allowance or more functionality allowed from the end user to use within our password application. Notice here in the code, you'll find the code in the repo. I will link it. Like, notice here the functionality of the checking and validating that. Notice the changes using GitHub log, and then also Notice all of those. And yeah, I think that's it. Finishing the first one, adding more feature to the password generator. Then let's do refactor for a more standard way of like handling errors. Um, I like error handling, the standard way of error handling within Rust. I did that before in my previous two tutorials, and simply you are just not letting your code or your library code to panic and stop the applications, but giving the flag of panicking or the flag of the decision to the caller of your function. So you just bubble up the error and the caller of your function will decide, should I like panic or should I like take some action or whatever. It's not on you to panic and stop the application. So here will first get with the arguments, we'll first refactor this. I will use like the results in them. So, and here I'm returning self, or I like using the create object box dynamic error, and then I cast everything to this. So it's dynamic thing. Here it's complaining for sure because it needs the OK enum to return, and here I don't think we have. Yeah, we need to remove the from arguments. I believe we use from args in safe mode. Yeah, because the safe mode that is the one that can like return errors, not just. It's like using unwrap. It can return the value or return an error. Same thing from args safe. So this is fine, but like the one that is using it, it's not yet optimized. So if you can see, like we are using this private function internally without the live. So the password new is using it. So and now this is complaining because we are returning here a results enum. So I need to figure it out. So here in the arguments, I need just to make it like that. Yeah, and here let me add as well like results enum, self, or same thing, box error. So yeah, this if this gets bubbled an error, it will also bubble from the new. And the error will be coming from here, from the library. So the library reduce or gives us an error, and then we bubble it up to the caller, which is new, which will bubble it up to the user of our argument or the user of our library, sorry, in here in the main function, or anyone like using it in his or her code. So I refactored this. It's now like this will return an error. Let's check everything. Yeah, this needs to be as well wrapped within the OK num. So I believe it's good. Yeah, here instead of panicking, we can just return like error, the error enum, and here we can must character, must like at least one character. Yes. Yeah, the question mark here is for return. I can replace it with the word return. And I believe this needs to be wrapped into. So yeah, I think we're good. It's this or the question mark, like anything that you prefer. Like this is a formula, like you return an error and then you cast this string literal into the type of error that will be bubbled up here, or you can just return an error with a question mark. Same thing. I prefer like let's this time use the question mark. It's more as a shorthand. Let's test that everything works. This time I won't pass anything other than the length. It shouldn't panic. It should just print an error enum. And as you can see, the password entity is, and it's an error enum, and this is coming from the main one. Yeah, this is coming from here, and because it's like uh, prettified, it can print whatever the content here. So just printing the error. You know. I think, yeah, I think that's it. Let's commit. Yeah, let's complete the task. The second one, do the refactor. And then, yeah, let's test it a bit more before we commit. So I will use all the flags. So I use uppercase, lowercase, I use numbers, and I use special characters. And as you can see, it's giving me a strong password. I'll use it one more time. Yeah, let me add maybe 80 characters, and then let me just add it as special characters. Yeah, as you can see. That's a good point. Let's add another validation here. Let's say we want our application just to generate maybe maximum of 80 characters. So here we can just check on the args dot length. Yeah, we can add this here and the password, and as well we can use it here. I prefer, like, I think if it's the earlier the better. I remove it from here, and then I will add it here in the list. But first, let me comment this. So we did the refactoring, and also we added new features, allowing more characters, set types within the password application. Okay, now let's add one final validation. So here I just check if the length is, yeah, if it's less than 5 or greater than um, maybe 880, sorry. So yeah, we should return an error. Let's give it a try. So let's say cargo run separator and then length of 90. Yeah, it's returning an error, and let's say 1. Yeah, so we are good. Let me comment that. Password validation. Okay, I think that's it. So that's the checks as well, this one. I think that's it for this episode and for the whole tutorial. I hope you liked it and it adds value to you. Please let me know what you think, and I'm open to feedback, I'm open to questions, and feel free to reach out to me here or on LinkedIn. Check the code on GitHub, let me know what you think. Also open for suggestions for like new episodes. And yeah, can't wait to see you in the next tutorial. Thanks and have a great day. Bye bye.